All right, welcome back. Today, we're jumping into something really cool happening in AI. We're not just talking about AI that can write a poem or chat with you. We're talking about a whole new kind of model that seems to, well, think differently. So what's actually going on under the hood? Let's break it down.
So, let's kick things off with a paradox that I'm sure you've noticed. You see an AI create this absolutely stunning piece of art or write flawless poetry. But then it completely bombs a logic question a 5-year-old could get right. I mean, what is up with that?
And this contrast really gets right to the heart of it all. On one hand, you've got this machine that can whip up a perfect sonnet in seconds, following all these complex rules of rhyme and meter. But on the other hand, for years, that same machine could fail at something that seems so simple, like counting the number of R's in the word strawberry. And look, that's not a bug. It's actually a massive clue about how these models have traditionally worked. Which brings us right to our first big idea. Brilliant guessers, but bad reasoners. See, we've got to understand the basic design of most AI we use every day. They are incredible guessers, but historically just awful at reasoning.
So what's the core mechanism here? Well, most of these big language models are trained on one really simple but incredibly powerful goal: next word prediction. That's it. By just plowing through trillions of words from the internet, from books, from articles, the AI learns grammar, facts, and all sorts of patterns just by getting really, really good at guessing what word comes next in any given sentence.
Yeah, and researcher Jason Wei put it perfectly. He said this whole next word prediction thing is kind of like System 1 thinking. That's a concept from psychology. It's our brain's fast, automatic, gut-feeling mode. It's what you use to finish the sentence, "the sky is," without even thinking about it. Super powerful for sure, but it's not deep, deliberate thought. And that's the real bottleneck with that System 1 approach. The model spends the exact same amount of computer power, the same amount of effort to answer what color is the sky as it does to solve a super complex multi-step physics problem. It's just guessing the next most likely word. And that's exactly why it falls flat on its face when a problem requires actual, deliberate steps.
Okay, so if the old way was a fast brain, the new solution is all about building a slower one. Researchers started asking, hey, what if we could force an AI to do something more like our slow, deliberate System 2 thinking?
This led to a huge breakthrough called chain of thought, and a foundational research paper showed this perfectly. So you give a model a tricky math problem. The old way, the pattern matching way, it just spits out a nonsense answer like 27 apples. But with one tiny change to the prompt, just adding the phrase, "think step by step," everything changed. The model was forced to show its work, right? It laid out the logic, step by step, and it got the correct answer. The takeaway here is just massive. Making the model explain itself actually makes it smarter.
So what's really happening here? Well, we're basically cranking up the dial on what's called test time compute. Instead of the AI doing one super fast pass to just guess an answer, we're letting it use more processing power right when we ask the question. It's almost like giving the AI permission to just think longer and actually work through the problem.
And this didn't just happen overnight. This whole capability has evolved through a few different stages. At first, it was just a user trick, a simple prompt. Then, researchers started explicitly training models on huge data sets packed with step-by-step answers. After that, we got reinforcement learning, where the models were actually rewarded for finding the right reasoning path all on their own. And now, we're starting to see reasoning become a core, built-in part of the AI's actual architecture.
And chain of thought is really just the beginning. The newer techniques are even more sophisticated. You've got tree of thoughts, which lets a model explore a bunch of different logical paths at once, almost like a branching decision tree. Then there's self-consistency, where the model just generates a whole bunch of different answers and then picks the one that shows up the most, kind of like taking a majority vote on its own thought.
Okay, so this all sounds incredibly human, right? But here comes the reality check. Even with all these amazing advances, it is absolutely crucial to remember that AI reasoning is still fundamentally different from our own. Let's start with how we learn. Humans learn through something called neuroplasticity. Our brains physically rewire themselves based on experience. You touch a hot stove once, and bam, lesson learned for life. An AI, on the other hand, learns through something called backpropagation. It adjusts millions of tiny mathematical weights over millions and millions of examples to slowly get better. It needs to see a concept thousands of times to learn what we can often get in a single go.
And what about how we process information? When you hear a sentence, you're not just hearing words. You're grasping concepts, you're getting ideas, and you're linking them to a whole lifetime of context. An AI doesn't process ideas.
It processes tokens, basically just little chunks of text, and it calculates the statistical relationship between them. It's a world of pure math, not meaning.
And our memory, it's so rich and associative. You know, the smell of rain might instantly remind you of a childhood vacation. It's this incredible web of meaning, context, and emotion. And AI's memory is its context window, just a short-term buffer of the most recent text. Once that window fills up, whatever was at the beginning of the conversation is just gone, completely forgotten.
But maybe the single biggest difference of all comes down to one critical concept: embodiment. We humans are embodied. We exist in the physical world. Our understanding of things like heavy or wet is grounded in direct, physical, sensory experience. Look, here's a super simple way to think about it. I know that if I drop this marker, it's going to fall. Not because I've read a million documents describing gravity, but because I've lived my entire life with it. An AI only knows about gravity from text it's read. It doesn't feel it. It just doesn't have that common sense that comes from actually existing in the real world. Okay, so it's clear these reasoning models aren't human, but what they are is an incredibly powerful new kind of tool. And to really use them well, you have to interact with them a little differently. This is a big one because it completely changes how you should prompt them. With the standard chat models, the fast System 1 guessers, we've all learned to tell them how to think. We say things like act as a researcher or think step by step. With these new reasoning models, you actually do the opposite. You don't need to tell them how. You just tell them what you want. You give them a really clear goal, like generate a comprehensive educational report on quantum computing, and you let their built-in reasoning process do the heavy lifting. Oh, and one more thing you've got to keep in mind. This kind of thinking takes time, because the model is using way more computer power to generate a structured, well-reasoned answer. You have to be prepared for higher latency. This is not instant chat. A really deep reasoning task might take 30 seconds, a minute, maybe even more, so be patient.
So where do these things really shine? Well, they are absolutely killer at complex multi-step tasks that just totally overwhelm the older models. We're talking about things like deep research and generating detailed reports, complex coding and debugging, multi-step planning and strategy, data analysis. You can even use them as an impartial judge to evaluate the output of other AIs. These are the kinds of problems that demand that System 2 thinking.
And that brings us to our final thought here. It is crystal clear that AI reasoning isn't human reasoning. It's computational, not conscious. It may never be. But honestly, that's what makes this so fascinating. The real question is what becomes possible when we combine the best of both, when we take our embodied, conceptual human minds and pair them with an AI's tireless, logical, step-by-step processing. That's the huge question these new models are asking all of us to answer. Thanks for watching.